Okay, hello everybody. Welcome to QCon. Welcome to Powering Public Infrastructure with Kubernetes. Is my voice level good? Actually, can everybody understand me? Yep. Okay, perfect. So I'll be talking today about powering public infrastructure with Kubernetes, and we'll have a small agenda. First, I'll do a project introduction, so what we are doing exactly from a business point of view with Kubernetes. What's the platform we chose, the stack we decided on, how we're doing continuous delivery in an enterprise of our software product, and what the future will have for us in terms of Kubernetes and the business. So I'm a technical architect working for Accenture. I'm working in the containers platform groups, and my work is mostly focused around Kubernetes. So everything containers and container orchestration in terms of Kubernetes is where my work is done. I'm based here in Berlin, so I actually could cycle here. This was interesting experience. And so for this talk, I made a couple of assumptions. So everybody who's here, I think, falls more or less, hopefully, in these categories. I think everybody here should have a basic understanding of Kubernetes and have heard of containers already. The next thing you might be here is because you're interested in implementations of emerging technologies in enterprises, because Kubernetes is still a majoring platform, and delivering a project with Kubernetes might be of interest to some of you. Or you're just plainly interested in what Deutsche Bahn or German Rail is doing, because in Germany, public transport is actually quite important. So there are many people who are just interested in what German Rail is doing. So what's this about? Deutsche Bahn consists of several divisions. So in this talk, I'll focus on one. We're at Station and Service, it's called. And basically what Station and Service does is they manage the stations in Germany. So every station, there are about 5,000, over 5,000 in Germany. They're managed by Station and Service. And that's mostly real estate, but also the operations of the stations itself, the escalators, the elevators, the information flow to the stations from the stations. And there are 30 million passengers daily in doing public transport in Germany, which is quite a lot. And actually, there's a lot of people flowing through public transportation. So this is a German ad for German Rail. It roughly translates in English to "the train is approaching," and this leads us to the question: when is the train approaching? Usually, or especially in Germany, when the train is not on time, this might be a major incident for you, because you have your routines, right? You want to go somewhere, and we at Station and Service, we are concerned about how this information reaches you. So how can you consume this information? When do you consume it? And also where. So one consumption point is the display here, which is on every station, on every platform in Germany. And this is the visual consumption. So we have also audio and one or two other ways to consume information. And actually, this system consists of quite a lot of services to deliver you this simple information. It might look like not that complicated, but we have currently running over 30 microservices delivering this information. It's more or less lots of rendering engines and lots of rules engines involved because, well, of the complexity to route information. Where are we doing it? As I mentioned, in all of Germany. So there are over 5,000 stations, and in those stations, over 40,000 trains and 30 million passengers commute daily or travel daily, which is, well, you might say at scale. So what exactly are we doing with Kubernetes? How does Kubernetes come into play here? Well, somebody has to deliver the information and process the information. So our system is basically running on top of Kubernetes, delivering this, processing this information, this scheduling information when your train arrives, and when your train maybe is late or it comes in the wrong direction. So what you might expect from an emerging platform like Kubernetes is powering, well, new technology, right? The beta stuff, something really exciting. And actually, we kind of have very much legacy systems we need to power. We need to deliver this information to. So, for example, one or actually two you see on this picture, we have the displays of several generations. And this is this was one of the reasons why we chose why German Rail chose to unite these different manufacturers on one platform, which is currently in implementation on top of Kubernetes. Historically, these displays were made by hardware vendors, which is nice, but they were also delivering the software on top of these displays. And there were quite some challenges because historically there were many vendors involved over the last couple of 15 years maybe. And all this process of talking to the vendors, of doing the API contract between the platform and the actual system running, all these difficulties talking to different vendors was kind of a challenging situation. And also the back end was kind of historically grown, so there were many systems doing more or less the same, but each one has its benefits. And the new system will basically unite all the other systems, succeed all the other systems, and it will also be directly involved with the hardware because we deliver now the software to run on these displays. So we have a nice package. We have also the client on our side, and we can do the server as we wish, the backend. So yeah, we are actually also delivering the client OS on those hardware. So German Rail still doesn't make the actual hardware for the displays, but the software is coming from German Rail. So how does this fit with Kubernetes? When we started the project about almost 2 years ago, the container landscape was quite new. In fact, many of these systems were non-existent 2 years ago, and this list is non-exhaustive, so don't take it as a Bible here. But these are kind of some technologies we looked into, and I want to focus here, funnily enough, all the speakers prior to the KubeCon, they got a message from the organizers to not make fun of other container orchestrators. And I think 2 years ago, that was still a challenge. When I think back, 2 years ago, there wasn't really a one system who you would go to deliver a next software project. But right now, the platform of choice is pretty clear. So I think lots of people have chosen Kubernetes for delivering their projects. And back then, when we started, it wasn't quite clear. So we had all those choices. We just wanted to make sure we're running bulletproof for the future. So what's the final stack we ended up? So obviously Kubernetes. That's not such a surprise because I'm here. Obviously Docker, because it's simply the most well-tested runtime for containers. It was back then, and I think it's still quite now. it has its bugs, but all the other implementations which were out there were kind of even more immature, and you had to do even more yourself. So we just went with Docker. And the story of the upper layers, for example, we have the infrastructure on the bottom and the workflow approach on top. And the story for the workflow, it was a bit blurry for us back then, because we didn't know, there was no experience delivering containers as a non-Google enterprise, I would say, or non-AWS enterprise. So I refer to these consumer containers as Kubernetes, and there was no clear story to manage containers. Well, there was a story to manage VMs, applications on VMs on top of cloud providers. And for us, it was pretty clear we didn't want to have Ansible or Chef for describing the actual software. So for the infrastructure, sure, it might make sense. You need something to roll out or to provision your infrastructure. You will need something like that. But for the actual application deployments, we didn't want to go the route to do Chef or Ansible or Puppet or SoulStack or whatever there is, because that's usually some description language not everybody is familiar with, and in the end it would end up doing in the ops department. So the infrastructure guys, they have to help all the time with application deployments, and it was pretty clear we didn't want to do that and do this route. So why do you so your question might be, there's AWS on the bottom, so we're running on AWS. Why not just use the AWS primitives? You're on AWS anyway. That's a fair question, but we weren't always on AWS, right? So when we started at an enterprise, there was getting compute resources was actually quite a long and daunting process. We couldn't just go somewhere and say, okay, give me 16 instances of this hardware and give me the IP address and give me an API for DNS. And give me it in 10 minutes. So this wasn't possible. There was lots of bureaucracy involved. We had to fill out forms, and the provisioning process took, well, weeks or months, I would say. So, and as a product or as a project, you don't have this time to wait. So you need to start, well, right now. So we ended up buying a few toy PCs. Actually, they are not so toy, but compared to the other systems, they are. So, but they had, I think, a 4 or 8 core i7 and 8 or 16 gigabytes of RAM, and we had 3 of them. Well, because you need kind of 3 for Kubernetes, and we run the good portion of the first year on these small systems, and it worked quite well, actually. And one of the main points for that was because the final destination for our software, it wasn't quite ready yet. So it was uncertain. We didn't know where we would run on. The AWS frame contract was still a negotiation, so we couldn't just bet on AWS and using some nice AWS products to deliver. This wasn't possible. And from a project perspective, this was challenging, but it was a huge benefit in the end that we were flexible with our infrastructure, because we evaluated the system we chose for, or the platform we chose as a foundation based on these constraints also. Yeah, the next move was to, well, what I blatantly call private cloud here, because nobody knows what a private cloud really is, right? We had some Dell servers there where we have an Accenture system running, and we kind of have a more serious system for testing and developing the software product on top of Kubernetes. And that was actually pretty good. There was lots of resources compared to before. But fortunately, in the end, we got the green light for AWS, so we could move to AWS, and well, that was pretty good actually. Because otherwise, if we had AWS from the beginning, I'm not so sure we would have chosen Kubernetes, because Kubernetes on AWS is kind of a difficult story. There's no managed product, so you have to, more or less, you have to do everything yourself. There are some help from companies now, like Heptio and CoreOS. They are delivering products who are focused on AWS, so you can use them actually and make the experience a bit more convenient. But if we had the option of AWS 2 years ago, I'm pretty sure we would have go for AWS. So that brings us to the next question: is how do we do DevOps with with all those microservices? I'm not sure if I mentioned, but we have right now we have around 35 microservices running on top of Kubernetes, all as a single application stack, full end-to-end stack, and these 35 microservices, we are still in developing mode, so we are just adding features to the platform. We are still collecting requirements from the business owners. What do we have to do next? And so we're still growing with the microservices. So there's, not an end in sight. Maybe we end up at 40 or 45. And yes, actually, so for a single environment, that might be easy to manage. But we have kind of lots of environments. We have not only dev environment, but you also have the testing environment, the customer integration environment, performance testing, all those sprints you do, and all those releases you do. So all those stuff has to go somewhere. And it's not only the single application stack, because it's not always all your applications at once. You also have these continuous delivery of each and every software in this stack. So there comes this version complexity also towards it, the dimension. How do we manage these version complexities? How do we deal with the environments? And there's just one answer to that right now, if you're focused on the integration perspective, and that's kubectl. So all of our developers have cluster access, obviously, for the namespaces. And actually, there's no need for AWS access. We don't have any of actually there's only a very small group managing AWS. And since we're a custom dev project, so we don't use too much of the other software products AWS has to offer, like there are many. We are more or less just delivering custom software here. So we get away with just delivering or handing out kubectl access to our developers. And that's actually pretty cool, because we can manage these credentials and the permissions natively in Kubernetes, in the platform itself we are running on. We don't have to manage many things on AWS. In fact, lots of things Kubernetes manages for us, like persistent volumes or load balancers or Route 53 entries. So all these manual things are a thing of the past, and whenever we have the option to go to channel something through Kubernetes to the underlying platform, then we go this road. And for developers, it's actually pretty easy, because they care about the application, right? So they're focused on the application. They want to know, is it running? How long is it running? What's the logs? Can I restart it? Where is it running? In which environment is it running? And all this you can do with kubectl. It's just a process manager for all your applications in a cluster, like local Linux tools. So now that I can run containers and manage them, that's nice. But what about the code? How do we manage getting there? And that's also not so easy, because there are many options. I've listed a couple of them here. So I'm sure everybody knows Jenkins, because lots of people use Jenkins. There are some other things you might like as a developer experience on top of Kubernetes, which is Fabricate is another one which is pretty good, and we evaluated it, but it's kind of opinionated. And in the end, we chose GitLab Runner because it gives us the most flexibility. We were kind of fans of Golang, Concurs, or Spinnaker. We evaluated those tools in depth. When Spinnaker went native with their Kubernetes integration, that was kind of a big deal for us because, well, we kind of liked the approach. But in the end, it turns out it was very opinionated, and we kind of evolved with the GitLab CI and the GitLab project as a whole, because GitLab itself, it went more in the direction of a software development and software delivery platform. And this was a good thing for us because we started small with those GitLab runners. I'm not sure if you're familiar with that, but that's everything is available on premise. Oh yeah, maybe that's another thing worth mentioning. Everything we had to run was on premise, so there was no option for us to use any of the nice software as a service products out there. So that means no Slack, no CI in the cloud. Well, no other nice integrations you might use from the public cloud. So we had to run everything ourselves, and we still are. And actually the GitLab Runner was one project which evolved with us, basically. And in the end, there was no need to switch it out to a different CICD approach. So next I want to talk about the auto-scaling of the CI. It's a bit of a technical feature. I hope you don't mind. Because I like the approach. When we started at the beginning of the project, everybody was excited about Docker, and we were pretty excited about that you can, as a CI, the project can deliver Docker containers as their build containers, as their testing containers, right? So no more of going to the infra department and planning to just install this version of Ruby or this version of Java into your CI. So you just deliver the Docker container and the Docker image, and you run your own code or your own testing code in the CI. So that's you can do it yourself. You have to, you can do it yourself. And that was pretty nice, but I think the better thing now is that we cannot only hand out these responsibility to the application developers because they know best how their application should be tested and should be run, the environment. But we can also run the CI itself as a container, as a pod in our cluster. So that wasn't possible 2 years ago. We had a kind of static builders, and then you have either you have to come up with your own flow of autoscaling the builders in AWS, but that would be custom development or looking at other integrations. So obviously the right approach would be to just build on your cluster. You have abstraction of compute resources, so you might as well use them. And this is what we can do with GitLab now. There's a Kubernetes executor, which just spawns. It just spawns a pod for your testing stage, and it executes the code which is in the GitLab CI YAML file, and it will just do that. So what you can do right now is we don't actually right now, but what you can do is you can build a heterogeneous Kubernetes cluster with you taint the one nodes with applications workload, and the other nodes in a different auto-scaling group as a CI nodes. And then you hook up that to the Kubernetes scheduler, and whenever there's a CI job coming into the queue, it will watch the CPU load of these CI auto-scaling group, And whenever it hits a certain amount and reaches a limit, it will spin up new cluster instances in the ASG. And then your new CI stages can just build and deploy. Yes?
Why would you set it up in a separate autoscaling group anyway? Why you don't have one group that you autoscale for both CI and my app?
That's a very valid question, and the thing is that currently Kubernetes provides very good, or is in the process of providing soft isolation between environments or between runtimes and containers. But for a CI, you're not really sure what you execute, right? So there is the danger of hogging all these resources anyway via some kind of bottleneck via disk memory or unknown bugs in Docker, or so the risk of running that as part of your application workload. So we are not running prod and dev on the same cluster. That's for sure. But even dev, you have it's kind of prod-like if your developers are dependent on it. So you can't just really play around with it. So I think the more clean approach is to have a heterogeneous clusters right now. But maybe in a year or two when KVM CI maybe is an option, then this could be very well run on the same cluster. Okay, so we have these nice Kubernetes executors and autoscalers. So how can we deploy the software? We are using namespaces as isolated environments. This gives us nice separations of concerns. So actually we have lots and lots of namespaces because they're cheap. We can just create and consume them how we want. And the other thing why we're doing isolated environments in namespaces is we can set a default of a DNS name in the Docker file or in the Helm chart or in the Kubernetes deployment. And this default is it's just my go-to point. I don't have a FQDN inside my requirements of other software I use for my service. I just put in the name of the actual software I want to use, and if I'm in the same environment, I'll just consume that. There's nothing special needed. And if I want to have another environment, I'll just spin up a new Kubernetes namespace. And also the thing that you can do permissions. Roles and permissions in Kubernetes right now is focused on a namespace as an object or as an entity. So yes, I would advise to look into namespaces if you don't know them. So how do we manage deployments? I've talked about Helm a bit. Helm is a templating engine maybe for Kubernetes. It abstracts the Kubernetes internals away. So the idea is, as an application developer, you care about your applications and only about your application, right? You have the name, you have the number of instances you want to run, you have the capacity, you have maybe your requirements or dependencies, but that's it. I don't want to know whether these container image or all these container details, I don't bother with them. They should be abstracted away from me. And that's exactly what Helm is doing. If you haven't checked out Helm, it's basically, I think it's the future of application deployment for Kubernetes. And if you describe your application in Helm chart, it's pretty much a guarantee that you can run it on any Kubernetes or Kubernetes-based distribution cluster in installation, wherever you have. So I'm almost at the end. I'll want to quickly talk about a few challenges. So who has brought up a Kubernetes cluster? Yourself? Oh wow, that's quite a lot. So I'm not sure if you have done it via an installer or via hand. So we've tried some installers, but they're right now. So it's getting better, definitely with kubeadm. But when we started, there was maybe kubeup, but nothing else. So we had to do this bootstrapping process ourselves, which is, you learn a lot about Kubernetes, which is nice, but you want to do it only once and not every time. And the cluster upgrade procedure is, even now, it's kind of challenging. Doing in place zero downtime Kubernetes cluster upgrades. It's kind of a challenge today, but it gets manageable. There are approaches with self-hosted and kubeadm, which are really about the administrator perspective of bootstrapping a cluster. So that's a huge plus. I'm really looking forward to these benefits. I'll skip to that. So in the future, for our project, the Kubernetes side of things, we want to build on the Helm improvements. Helm is maturing every quarter release, I think. We want to build an app store so other divisions of the enterprise can easily consume our applications. There are talks of running OpenShift and other Kubernetes distributions in the company, so people can just consume our apps on their clusters. We want to move to RBAC, which is a very nice feature of 1.6, which came out yesterday, I think, and we're really looking forward to that. And of course, federation and failover, especially failover, because we're running public infrastructure. It would be nice if it's available all the time. So what's in the future for German Rail? I think stabilization, rollout to more stations. So I didn't mention that, but Kubernetes right now is not powering all the stations in Germany. It's powering selected stations where we have a rollout of these new displays. But over time, we will roll out to even more stations in Germany. So that's the goal, to go more into production. And Kubernetes or containers as a whole have to become boring. So as an enterprise, I don't want these fast pace of change and this rate of change. And we want to scale to 5,000 nodes because we have all those nice little displays running in 5,000 stations in Germany, and actually they are not so underpowered. So they have 2 gigabytes of RAM that might be able to run a kubelet. So that would be a nice scale. So this is my last slide. Join us if you want to work on Kubernetes or containers. And that's it. Thanks. Are there any questions? Yes?
You mentioned federation. What will be your main use case for that?
So the question was federation, what is our use case? And I think pretty much failover is the use case. So I think as a first milestone.
Between what and what? Between two AWS clusters or between AWS and on-premise?
All right, so we are running right now on AWS, and that's the network difference between from here to there is, this is obviously running on public, and AWS, the data center, is where our backends runs. And as a first milestone, I would say we're running the same application stack in a different cloud, or even on-premise, because we have the data centers. And the next thing would be to have a federated cloud, so to do these failovers automatically. Yes?
So how do you manage, maybe I missed something, but how do you manage the deployment itself? I mean, applying the Helm part. Are you using Helm? Do you use GitLab or other pipelines?
All right, so yes, the question was how do we use deployments as part of the CI? That's a good question. So we have a Helm repository right now where we push all our chart updates. And the CI is currently moving to a Helm upgrade approach. So in this GitLab CI runner, there's the stage which is called deployment. It's more or less at the end. It depends to which environment we want to deploy. Automatic deployment is going to dev. So we tag each commit or each Docker container with the commit hash, 8-digit commit hash. We build the image and we deploy it via. Right now we are currently transitioning to Helm upgrade, but prior to that we are using kubectl set image, just plain set image. But yeah, Helm upgrade is the way we want to go because we have huge stakes in the Helm approach of managing applications on Kubernetes. It has its limits, its limitations for the upgrade, especially because there are right now things. If only your config map changes, then you need to work a bit around it. But that will be the way. Yes.
I have a question. Where do you store the secrets before they actually deploy the secrets to Kubernetes?
Oh yeah, that's a good question. The secrets in Kubernetes, how do we do that? So there are a couple of choices to do that, because in the end it's hard to automate this process, right? Because secrets are kind of, you have to be responsible for them. You can't just check them in or somewhere. So you could use the GitLab CI for that as well. You can define secrets there as an administrator and inject it in your every time a runner executes a pod. For the real secrets, for the application secrets, actually we're not so much concerned about that, because we're running we're running in a very constrained internet in an AWS VPC. So we trust basically the applications which are running there. So we have most of the secrets are right now just in the repository, because we wanted these abstractions from secrets. So in case we need to move them out, we can just take the secrets and they're not hard-coded. But I think the whole secret story in Kubernetes is kind of developing right now. So there's lots of demand on how to do that. And people have different ideas and feeling how to solve these problems. And I think it will be very interesting to fast forward to the end of the year and see what's there at the end of the year. What kind of stuff can I look at? Yes? So yes, very good question for the GitLab. How do we install GitLab basically on the cluster? When there was a question. So when we started, there was a community maintained GitLab chart. We started with the community maintained GitLab chart, and because the application deployment is kind of is fast right now with Kubernetes, we just deployed the Helm chart over and over, and more or less moved every dot release to the new GitLab release. We haven't moved to 9.0 yet, because we are in the transitioning phase to the official GitLab chart of GitLab, from GitLab. And so we have a POC. We are currently testing it, the official chart, and I think it works more or less now, and we just have to do the transitioning. It was a bit challenging the last couple of weeks, that's why we haven't made it yet, but I think it's very much usable now. Okay, thanks. I think we're a bit over time, so thanks again for coming here, and if you have any questions, you can reach out to me directly.